Good morning, all of you. My topic is state-of-art approaches to question generation technique. This is the introduction of the topic. For that, we have considered one simple example where we have given some piece of code to the machine and machine have generated two simple questions as the output. Motivation behind this topic is like information retrieval and question answering. In information retrieval, when we type any single keyword in the Google, so Google will give us the whole document or Wikipedia file as an output. Means when we are providing a short input, we get a long output. And in question answering also, when we provide a question, we will get the respective answer of it. Next one is question classification. Question is classified on the basis of main classifier. Suppose main classifier are like abbreviation, location, numeric, description, entity, human. It can be any of it. And each and every main classifier will have its subclassifier also. Means let's suppose take the example of human. So human can belong to any group, any other group. Each group can have its independent name. It can have its title also. It can have its different description depending upon the different group and title, like that. Each and every main classifier will have its subclassifier also. So on the basis of this classifier, we will classify our question. In what category question we have to ask the question, in what. Like this, some other approaches are also there, where one of the author found or created the dataset named news cues QA. These are for news articles, and this is prepared from the news QA dataset and squad dataset. This is with the 20K question answer pairs available in this dataset, and which is derived from the 5K news item summaries. So mainly the multiple choice question where there are distractors and the correct answer. So the task is divided into two parts mainly. First one is the question answer generation and second one is the distractor generation. In question answer generation, we take input as a passage as an input, and we will get question and answer pair as output. And for the distraction generation, we will use this previous input, that is question and answer from the one part, and passage also as an input to the distractor generation, and we will get the distractor as output. Sometimes the text that the input given to the system, that is converted into the sentences. That sentences are tokenized, and after that, from the tokens we will get a corpus that is built as TF, IDF and Ngram models with the help of NLP tools and techniques. The keywords that are extracted from the lecture material are important words. For indicating this or for denoting this or for checking this, we have used the matrix, that is precision. And if all the important words in the lecture are extracted, that is found by the recall metric, and this all process is done through NLP. Like again we can perform this task with the help of a large Python library like NLTK, NumPy, SumPy libraries available. And another data set is also used for checking the accuracy of the system, that is the test papers or the national examinations conducted for the junior and senior high school mathematics subject, that can be used as a data set for checking the accuracy of this system. Here the system is mainly divided into the stem, mathematical equation, variable, and the fourth one is the algorithm for manipulating the stem or the template. So the it can be the equation, it can be the text, it can be the numeric image or data, or whatever it can be as an input. So how we will process such type of input? So for the equation kind of, we will use the variables and the conditions and operators with the given condition, and we will process it. And how the geometric figures will be processed? The from that geometric figure, whatever the condition are built from the figure or with the prescribed angle, that condition will be written and the angle value will be replaced, and one equation will be derived from that, and again it will be solved by using the normal equation. So that can be used for the trigonometric and geometric variables, equations and figures. And for manipulating the template with the requirement, with our for our requirement, for that manipulation we have used multi-part parser algorithm and custom media type parser algorithm. Again, for this task, for multiple choice question generation, we can extract domain terminology also with the help of word segmentation algorithm, and CRA based parser can also be used for this type of task. Then sentence extraction, for that text rank algorithm can be used, and semantic model of domain terminology establishment. Here word embedding can be derived. Basically for word embedding there are word to vec, glow, any word embedding as per your requirement we can use, and multiple choice questions are generated. And for more confusing distractor, for more accurate result, and for more rich information MCQ question, we use here semantic similarity between the different domain specific terminology. We will use the semantic similarity. Again, logistic regression, random forest algorithm, and lambda mart as a ranking model can be used for more accurate result. For that, similarity features like embedding similarity, part of speech similarity, token similarity, Wikipedia similarity can be used here. Feature based and neural network based supervised ranking models are used for this task, for such task. When we have to generate the question from knowledge bases, in such type of question, knowledge bases are the combination of the node and edges that will make a graph, that will make a knowledge base. So for processing the knowledge base we need some sort of embeddings, like sometimes knowledge base embeddings, word embedding, sentence embedding. We need the embedding values for processing it, right? So in such type of systems the model is basically based on encoder decoder architecture that leverages sometimes textual triples information like subject, predicate and object, two attention layers for triples and textual context, and part of speech copy action mechanism can also be used. Glove word embeddings and knowledge base embeddings are used. The decoder with maximum attention layers are used for capturing the minute detail. Then sometimes the encoder can use the embeddings, and LSTM also long short-term memories can be used in the encoder part, and decoder can also use LSTM network with attention and copy mechanism. So attention mechanism for incorporating the uh, vocabulary from the same input passage that we have inputted. Sequence to sequence model with copynet and attention mechanism is end-to-end trainable model which can be trained using back propagation. The objective of this type of training where we perform back propagation is to minimize the cross entropy loss that can be performed for generating the question from the knowledge bases. Then passage embeddings can be used, answer embeddings can be used for more accurate question generation or more answer specific question generation, we can say. So alignment network answer information is crucial for generating relevant question from a passage. So one soft alignment operation can be used here, which is made up of three main steps. First one is to compute attention score for each pair of passage word and answer word. Next one is to multiply the attention matrix with the answer embedding to obtain align answer embeddings for the passage. And third one is to concatenate the above aligned answer embeddings and passage embeddings to get one final embedding that we can further use for the bidirectional graph neural network. Uh, Here we can take one advantage that the cross entropy based and reinforcement based losses can be minimized here with the help of this type of architecture. Again, one setup we can perform for such knowledge bases are to incorporate the max pull pointer also. Next concept is to generate question visually. Visual question generation. This can be occur with the help of the doubly hint network. Double hint is one answer awareness, and second one is the visual hint prediction. So to infer which region of interest are suitable for asking question, answer clues and visual object features are both crucial. Visual object feature with respect to its background. If one image is given to you, so what that image is, what is the object, on what information we have to focus, and we have to uh, generate the question from that image is important. It has some major task. This type of system has some major task like answer prediction, how to predict the answer, like to uh, consider the region reference from where we have to consider the question, property of that object also we have to consider, position prediction, what is the position of that object with respect to the background, and visual hit prediction. Graph attention and image attention metrics values are passes through LSTM for such kind of visual question generation. For question generation, basically for question generation task, one concept is there, that is of scratchpad. For implementing this, we have used encoder of two layer by gated recurrent unit, bidirectional gated recurrent unit, and for decoder also we have used two layer gated recurrent unit. Globe vector embeddings are used for this type of task. What is scratchpad? Then scratchpad is a kind of operator. Scratchpad is a kind of operator that guides us for future generation by letting the decoder to re-encode the input at every decoding step. But how? By maintaining nodes on the encoder. Whatever the encoder gives us the output, that output will be captured by the scratchpad and it will be saved there as its memory, and that will be further used by the decoder. That is the work of scratchpad. Means here in this task no extra kind of memory for that history storage will be required, no extra GRU will be required, or no additional loss vector will be required here, because the scratchpad encoder will itself be act as a storage vector for it. Next one is question generation from adaptive neural network. For such concept, a copying mechanism is performed here with the bidirectional LSTM model with global attention mechanism. And why this all arrangement is done here? Copying mechanism with bidirectional LSTM and global attention mechanism also, for to improve its capacity for generating proper natural questions. We have to added the copying mechanism, and as a result copying mechanism to this neural model to incorporate original input vocabulary information in the decoding phase to generate proper question. Other type of question generation techniques, like we consider RNN encoder inside of our model. Suppose a new module like keyword net is a part of answer separated sequence to sequence decoder. One answer separated module is made, and that will focus on the answer only. Means what will be the answer of the question that we have to generate. That answer will be focused on this answer separated network, which combines both information from the passage and the target answer, extract key information from the target answer kept apart before. This type of sequence to sequence model has a tendency to memorize the sequence pattern rather than to reflect word meanings. Again, the sequence to sequence model with answer aware gated fusion encoder, attention based sequence model with the same enriched semantic and lexical features. Such type of In such cases bidirectional LSTMs are also used. We have considered the semantic and lexical features at the time of encoding that will help us to get more detail about the passage, about the sentences, or about the input we have given to the system. Because when we use the input as much as possible, then we can get the more improved questions. So answer aware sentence vector is used for the decoder. Sigmoid function is also used here for controlling the information flow of the sentence vector and answer vector. Sentence level semantic matching modules can be used. Semantic matching classifier is again used. Then bidirectional LSTM are used to capture interaction among sentence word condition on question. All this is for what? All this is done for improving the question generation by using separate answer position inferring that focus on answer position only. What is the answer position? When we will focus on that answer position, we can get more improved question. Like this, we can build one clue guided copy network also. What that clue guided copy network for question generation will do? It will maintain it will use a copying mechanism in sequence to sequence generative model. A clue word predictor is designed based on novel application of graph convolutional networks onto a syntactic dependency tree representation of each passage that will be able to predict clue words only based on their context in the passage and their relative position to the answer in the tree. What such type of network does? Clue guided copy network. For this, we will consider the uh, tree representation of the input. That tree representation will gives us the more closeliness between the answer chunk and the clue word as compared to the exact ranking position of the sentences. This is the overall architecture where we have maintained one separate clue prediction part which whose output will be the clue predictors, means for the particular clue this is important or this is not important, like that the indicators will be the output for the clue predictor, and this will be act as an input to the question generation system with the input context, and we will get our output questions. For this task, glow vector are also used for finding word embeddings. Named entity recognition, part of speech tagging, and dependency parsing are also performed on input. And finally, we will concatenate all the results and we will get the one embedding. Binary feature can be is also used here for checking if all the letters are in lowercase or not, and that will embed into the vector. Then BIO feature will also be used for answer position, for focusing on answer position. Word frequency feature will also be used for perform ranking. So all these are the state of art approaches for the question for the various type of question generation systems. Thank you. These are the references that I have referred.